Okay guys, today I want to go over motherboards and all the different components on them. Well, the majority of the different components. There are a lot of different chips that do different things, but the main things you need to be concerned with, I'm going to point out today. So probably the biggest one most people know will be your CPU socket. This is a AMD CPU socket. It's a PGA, pin grid array. Whenever you slide the socket in or slide the CPU in the socket, this is a ZIF, zero insertion force socket. It has a little alignment triangle there in the corner, and there is a corresponding gold triangle typically on the CPU that shows you how it aligns in the socket. So whenever you put it in, slide the door shut. It has a little arm that actually slides the entire aperture over. If this is not shut all the way, then the pins will not engage. So there's your CPU. This would be the heatsink for your Northbridge. Northbridge is a coprocessor. It handles mainly PCI Express as far as expansion cards go, but also helps talk to the RAM. We have our heatsink for our Northbridge, heatsink for our Southbridge. Southbridge controls slower things in the computer, like your Sata ports. These are Sata ports here on the side. You guys can see these. They're shaped like little L's. Serial ATA. One thing I want to say about serial ATA or Sata ports is some manufacturers will have some ports that are Sata 2, some ports that are Sata 3, especially in these older boards. Sata 3 would be much faster. You're looking at 6 gigabits per second versus Sata 2 would be 3 gigabits per second, and then the original Sata would be 1.5 gigabits per second. So these are your Sata ports. Then we've gone CPU. We have our RAM slots, our Sata ports, Northbridge heatsink, Southbridge heatsink. Southbridge is another coprocessor like the Northbridge is. It handles, like Sata ports for example, handles your PCI slots. It also handles the majority of your peripherals as far as the things that you plug into the machine that are external to the case. Let me see what else. This is our Cmos battery. It keeps our time and keeps all of our settings we've changed in the BIOS setup utility. Cmos stands for complementary metal oxide semiconductor. This basically keeps all of our settings. So if we make changes in BIOS, then those changes are kept by the battery. If the battery goes dead, then all of our settings and changes go away with it. So we have our Cmos battery. If you guys look closely, I'll zoom in on this a little bit. You'll be able to see MBIOS there on the board. This one actually has two. We turn the board sideways there. You should be able to see that. There's a main BIOS and a backup BIOS, so that if your main chip fails, then the backup is there to take its place. These are soldered on. That's what's called surface solder. They're soldered directly onto the surface of the board. They can be replaced. It's your basic input-output system. It is basically the operating system for the motherboard. It tells everything what to do whenever it boots up, frequencies, things of that nature. So there's our BIOS. Here we have a header for USB 3. This is our front panel header. This is where we plug in all the things for the front panel, like the hard drive activity light, power button, reset button, speaker, things of those nature. That they all go here. And those are typically labeled on the board. You should be able to see them here on the side, and it'll tell you what direction to plug in based on whether it's positive or negative. The really big ones you have to worry about are the LEDs because they do have a certain polarity. Your power switch and your reset switch they're normally open switches. So whenever you hit the power button, it just bridges two of those pins and tells the machine to boot up. Same thing with reset. Whenever you hit the reset button, it bridges those two pins and tells the machine to reset. So we have front panel, USB 3 header. This is a power port for a fan, system fan. This is another power port for a fan. You can't really see those. I think they're USB. Yeah, we have USB, 3 USB headers here. Then we have a COM port, communications port. Then this is for our TPM, Trusted Platform Module. Here we have a 1394 or Firewire port, and then this is an audio port. Looking at the bottom of the board, these are our PCI slots, and then we have PCI Express. So this is PCI Express by 4. This is PCI Express by 16. So one of the things you want to keep in mind whenever you're building a machine, if you're going to have multiple graphics cards in it, you want to make sure that you have multiple PCI Express by 16 ports. So this one has the same form factor, right? It's the same, the slot dimensions are the same. But if you could look really closely, you would see that your pins for your bus actually stop right about here. So if you were wanting to build a dual GPU machine, you would not want to buy a board like this, because you only have one PCI by 16 slot. This one's PCI by 4. So don't get me wrong, your GPU would still work. You just wouldn't get the performance you want. So here's a PCI by 1, by 1, by 1. And one thing I should note is that PCI by 1 will work in a PCI by 16 slot. It'll also work in a PCI by 4 slot. As long as the bus is there and the correct pins are there, it will work. So we could put a PCI Express by 2 in here, PCI Express by 4, which is what this is. If you go to an 8, the pins typically come down to about right here. So you wouldn't have the entire width of the bus. The device might still work, but it wouldn't work as it was supposed to. Let me see what else we have on the board. We have our main power port, P1 connector. We have one here for a power fan, for a CPU or something, front of the case, back of the case, whatever. Here's actually our CPU fan here. Here's our ATX 12 volt. This is supplementary power for the voltage regulator module. Typically, these higher wattage CPUs, they can't get enough power from the P1, so they have to have supplementary power to actually help them, because the like 140 watt CPU can't draw enough power from our main ATX port, so it has to have, this is an 8-pin ATX 12 volt to supply extra power for it. So something to keep in mind, depending on the power supply you buy for a board like this. Make sure that it comes with at least an 8-pin if you're going to be running a higher wattage CPU. Then on the back side of the board, we have, this is a dual keyboard and mouse port. It means it could be either. It can be keyboard or mouse. Then we have 2 USB, and this is an SPDIF port, optical port. We have a 1394 Firewire, 2 more USB, 2 more USB. These are all 2.0. Typically the USB 3.0 will have a blue plastic in them, whereas the USB 2.0 will have black. One of the other defining things of a USB 3.0, just being able to look at it and tell the difference between the two of them, is a USB 2.0 will have 4 pins, if you can look at the inside of the connector there, and the USB 3.0 will have 9. There are 5 extra back in the back. So we have 2 more USB 2.0, all of our audio ports, and then this is our Ethernet port for RJ45s, plug it in to get on the network. So this is pretty much everything on the board that you guys need to be concerned with. I mean, we have a lot of different things, like capacitors. We have a whole row of them here to balance out the power. Then we have jumpers. Here's a clear Cmos jumper here. That's one of the main things I test you guys on, being able to find all the jumpers and all the different things on the board. Of course, we have system crystals and things of that nature. But we typically, as technicians, never really mess with any of that. If we have, you know, chip level things going out on the board, we typically just have to replace the entire board. Now, some of the electronics technicians can replace these chips, but being able to buy the chips to replace is pretty difficult from what I've seen. So that's it for this video, guys. This is what a motherboard looks like, and those are the major parts you need to be concerned with. Thank you.